Availability. In a nutshell, high availability is just additional hardware elements to eliminate a single point of failure, as we can see on the screenshot right here. The high availability, the FortiGate clustering protocol is a proprietary HA solution. They use is going to run on top of TCP 703, and it's just going to its main goal is to minimize downtime on an event of a failure for one of those firewalls. One of the key considerations for the HA is that it's going to require dedicated links called heartbeats between the firewalls for the communication and synchronization of the sessions to work. If a link fails that we are monitoring, we need first start monitoring the links. But if one of the links that we have under monitoring fails for whatever reason, maybe the port went down or we don't have connectivity through that port, then that will trigger a failover event. If we have a loss of power, if one of the units, since both units are monitoring each other through the heartbeat link that we have, then it will detect that that device is no longer available. Something happens to it and it's going to take over, causing a failover event. Is also a hard disk failure could trigger a failover as well. We need to enable that within the HA configuration with the set SSD failover enable. Some of the requirements for the HA cluster to form. The FortiGates, they need to be the same model, they need to be in the same firmware, and the license level needs to be the same. And this is just to guarantee that all the features that we're configuring, like maybe inspection or different type of VPNs, are also going to be available on the second unit when a failover happens. We can set up a priority to elect who's going to be the master of the HA cluster. And this is just to have a primary unit and our backup unit depending on our design. We can have two type of high availability modes. The active mode, where both units are going to be handling traffic, and this is accomplished with multiple VDOMs, and we're going to show that during the lab. But the most common one is going to be active passive, where one unit is handling all the traffic and the second unit is just synchronizing those sessions in case of a failover event, just to take over immediately. Since now we have two units and they're going to share an IP and they're also going to share a MAC address, that MAC address is going to be determined by the formula we have on the screen. The virtual MAC address is going to be 0090F09 in the group ID that we define during our HA configuration. So this is very important because if we have multiple HA cluster in our environment, we need to make sure that group ID is different to avoid a duplicate MAC address in our environment and prevent conflicts. The HA heartbeat, as we mentioned earlier, is going to be that link between both units to talk to each other and synchronize the session. It's recommended to have more than one link as well there. The HA link fail signal is going to shut down the interfaces for a second during a failover event. And this is when Obviously unit 1 is not completely down. Maybe the failover event was triggered due to an SSD fail, or one of the monitor links went down, or we are manually forcing that failover event to occur. If we have the link fail signal enabled, what is going to happen is that all active unit, while it's transferring all the information to the passive unit, while the failover is actually happening, is going to shut down all its interfaces, and there's going to turn them on again. And this is more as to help devices connected to the firewall, especially older devices that are not very good updating or accepting Gratuitous ARP messages. So that way, the devices connected to their environment will kind of be forced to relearn the MAC information, since they noticed that that port was disconnected for a second, and that way those devices, not the firewall itself, is going to have better transition after the failover has finished. So this one, it is helpful for other devices. It doesn't necessarily going to make our failover cluster or failover process better. It's to help things connecting to our firewall to have an easier transition as well. We can check the HA status of our cluster through the GUI under system and the HA. We're going to see that on the lab. We can also do it through the CLI, very simple. When the cluster is out of sync, meaning it's not able to have the same information on the sync tables or configuration files, there are a few ways that we can try to force that sync, but we need to make sure both units are in sync so we can have a smooth transition. And this is a snippet in the dashboard, not necessarily the system HA page that we saw in the previous slide. But we can have the HA status as one of the widgets in our dashboard. This is another snippet of how it's going to look within the system HA page. And we can see what's also the HA sync status from the GUI from that page as well. And from the CLI, we can check what's the status of our HA cluster with the get system HA status command. It's going to give us a lot of rich information on how our cluster is behaving. We can also use the get system HA command, it's just more condensed information of our cluster. Another command that will help us to determine how well or how bad our cluster is performing is the diag hardware device info and a particular NIC or interface. And we just want to make sure that the virtual MAC address, once the HA cluster is online, was applied to that particular interface. That way we can confirm, one, we don't have duplicates on that particular segment of our network, but also that the HA cluster is indeed working and is applying that virtual MAC address to the interfaces that we need. Another command is going to be the diagnose system session list. Will tell us if the sessions are being synced with the standby unit. And also we can double check from the standby unit perspective how many sessions are being synced at a given time. Lastly, one command for troubleshooting is going to be the diagnose debug application HA talk -1. -1 is just going to accept, we're going to debug all the messages for the HA communication and process. But for the most part, if they are not in sync, we can force that with the resync command. I think it is. I will double check that in the lab. No, I don't know. I don't want to say that. And finally, for additional troubleshooting, we can use the diagnose, debug, application HA talk command to debug in more detail what's going on with our HA process. Easy peasy, the HA doesn't have too much going on. Let's remember that runs is a proprietary protocol from Fortinet. It is going to run on TCP port 703, and the troubleshooting commands that we could use to confirm the status of our cluster. Okay, so let's go to our lab environment, and we are going to configure HA with our firewalls. So this is the environment that we're going to play with. Just very simple in comparison of what we were doing before. And we don't care too much about the IPs and details here. Just keep in mind that on the right, on port 4, we have the 10.1.5 that's 0/24 subnet with a particular target of 10.1.5.2 IP. And between our firewalls, port 3 is going to be used for the heartbeats. I know that during the slides we mentioned that 2 was recommended, but this is a virtual environment. It was the lab and it was easier. But on a physical environment, always try to use 2 links for your heartbeat. So if we go to firewall 1 over here, very simple. We have our interfaces. They are configured with some IPs, which for what we are doing today for the HA, we don't care too much, and already has a policy just allow all, so we can just configure HA. If we go under system HA, we're going to set it as an active passive. The device priority, I'm going to leave it as default 128. I'm just going to lower it on firewall 2. The group name is going to be Stormwind. The password, I'm not going to enable session pickup, which is highly recommended you do, but I just wanted to show you what's going to happen when we have that setting disabled. I could set up what's going to be my monitor interfaces. In case one of those interfaces present a failure, we're going to trigger a failover event, but we're not going to do that for the moment. A heartbeat, although is required, is going to be port 3. And I'm going to enable my management interface reservation. So that particular port is not going to sync, or the IP, I should say, for that particular port is not going to sync with the HA. So at least I have a way to connect to the firewalls independently. And we're going to enable the unicast heartbeat since we know what's the IP of our target. It's going to be 10.1.0.253. I'm going to click OK. And we go back to firewall 2. Firewall 2 has the IP configuration, but doesn't have, has limited IP configuration. See, port 2, port 4 are not configured because we're expecting that information comes from firewall 1. And this is useful if we have like an existing environment and we just want to add HA. We don't need to do much with firewall 2. We just need to add it to the cluster C policies. We have nothing there because we're expecting to sync that information coming from firewall 1. It's going to be an active passive as well. Priority 100. Group name, this needs to match. It's going to be Stormwind. Password also needs to match. Again, I'm not going to enable session pickup yet. Port 3 manage reservation is going to be in port 1. Unicast heartbeat is going to be 10.1.0.254, and we're going to click OK. If we go back to firewall 1, let's see, get out of there. Go back to HA. There we go. So now both firewalls are already talking. We can see that they have detected each other we have some the host name, the priorities, and since firewall 1 has a higher priority, it should become the active node for the or HA cluster, and some other information there. So the synchronization might take a while, so with magic of editing, we're going to speed up the process. So while this is syncing, I want to just show you something. If we do a get oops, is HA class checksum. Oopsie. What? Well, sorry, it's diagnose system HA checksum cluster. Yes, they haven't synced. Oh, perfect. It does take a little bit, but I wanted to show you. If we do that command, we're going to see what's the information that each firewall will have. And as you can see, and I only care right now the last two. For the global checksum, firewall 1 is reporting, I'm sorry, these local firewalls, firewall 2 is reporting an E915, which is not what the other firewall is reporting. Same for the root database and synchronization files, and from the complete synchronization file. They're still not in sync. And this command is useful when we are having HA problems. See, it's still not in sync, it's complaining about it, but they're going to keep reattempting for a little bit until all the files are in sync. If they don't sync, we can still force it, so that will be a good demonstration. So it's still reattempting. But yes, but this checksum command will help us to know which particular section is broken. If we go back to the firewall, let's see, it's not there yet. If you hover them, so it's going to say, well, there are 3 tables out of sync. It's the system global, and see, this is the information, pretty much the same checksum we were looking at before. The system interface, remember, firewall 2 had no interface configuration really versus system admin. I don't know where is that. Why would that be failing there? But it's just, see, they are detecting what are the changes and how they need to resync. So still not in sync. One command that we could use when the synchronization takes a bit, which I think already did, we can do diagnose system HA checksum, and we can recalculate the checksum, try to force those files to get overwritten on the secondary unit, since obviously the primary has the true source of information. And let's go back here. Well, actually kick me out. Checksum cluster. Perfect. See, 06 is 712, 06 is 712. So the recalculate forced that, and now both devices are in sync. Okay, perfect. So now that we have the devices in sync, let's double check something. We don't need you guys. Thank you. Oh, well, we can also see a check system HA just for general information about our configuration. The group name. See, the group ID is 0, and remember the MAC address gets compute from that value. So if we need to, we can edit that from the CLI. The heartbeat is going to be port 3 and other different values that we have here for HA. So let's try this. So I have ready it's another firewall, but really it's just a computer that is on the right side on port 1 and is trying to hit our target on 10.1.5.2. So if we do a execute ping 10.1.5.2, that's going to work if we go to the firewall and we do a get session list and we do a grep on our target IP 10.1.5.2. we see we have a session for ICMP. That session is going to expire in 45 seconds, 43 seconds. But the point is that session exists in firewall 1. But if we go to firewall 2, that session is not going to be there. If we do execute SSH, admin 10.1.5.2, and oopsie. And see, this is my target as well. If we repeat that command here, the ICMP is still there, about to time out, but now we have a TCP session as well on our entry, but it's not on firewall 2. So if we don't enable the session pickup, those sessions are not going to be synchronized with the standby unit. And when we have a failover event, those sessions will have to reestablish. For a particular situation here, our SSH session is just going to drop. If we have a browser, maybe someone is connected to, I don't know, Facebook or things like that, that could potentially recover because the browser will have some other information like the session cookies and other information in it that will allow it to recover. But there are going to be things that are not going to be able to automatically recover while the session pickup is not enabled. We can enable that from the GUI under config system HA. We do a show, we were going to see the configuration that we enabled previously. And then command is set session. Session pickup enable. And we close that. Let me close this. Exit. We're back to our target computer. And let's clear all the sessions that we have active. Oh, already. That closed. So we're good. So let's try that again. And let's connect back. We are in. We have a TCP session back on our firewall 1. Let's see if that's on firewall 2. And then, perfect, it is. Let's try now. Let's get out of there. The probably is going to drop. Yes, it did. But now let's do a ping. And this I need to be kind of quick here. But see, the ICMP is still not sync between devices, and that's because by default, stateless sessions like ICMP and UDP are not going to be synced by default. That requires an extra command, which is config system. Oopsie. It's always under configuration system HA. We do a show. We now have the previous one that we set up earlier, the session pickup, but that's going to be just for TCP sessions. Session pickup, oopsie, is connectionless, pickup connectionless. It's the other one that we want. And this one, see, as you can see here, is going to be for UDP and ICMP sessions to sync. We're going to enable that now, whoopsie, and enable DND. And so let's go refresh that a little bit. Okay, we don't have anything. Let's try that ping again. It's there. And now it's also on firewall 2. Okay, so why this UDP and TCP, I'm sorry, ICMP and UDP are not enabled by default with the session pickup is just because by the nature of those protocols, in which UDP is stateful and ICMP only cares about the first ping and the second ping and the return ping, and that's it, that's the whole session. We don't necessarily want to consume those resources, and we know those type of sessions or connections during a failover event will be very easy and quick to recover. But we need to always understand what type of traffic we have in our environment, because voice over IP, for example, the RTP protocol, real-time protocol, runs on UDP. And if we drop that session during a failover event, that call is not going to recover. Someone needs to hang up, call again to recover that. So we need to understand what type of traffic we have in our environment to know if we want to enable these settings or not. But that's HA in a nutshell. So hopefully that was helpful. Thank you very much.